Welcome back. In this video, we're going to start subsection 7.7.2 on continuous conditional distributions. Definition 7.7.1, let x and y be jointly distributed continuous random variables with joint probability density function f of xy. The conditional distribution of x given that y is equal to y naught has probability density function f sub x given that y is equal to y naught of x given that y is equal to y naught of f of x y naught, so that is the joint density function where we plug in this constant y naught value, divided by f sub y of y naught, where f sub y of y naught is the marginal probability density for y, and this is valid over the appropriate support. So like when we were looking at discrete conditional distributions, the support, the values that that here x may take, can change given a certain fixed value for y naught. And we notice also a corresponding structure of the joint, this time density instead of mass, divided by the marginal, the same as we had in the discrete conditional case. Part 2 just flips the variables around. The conditional distribution of y given that x is x naught has probability density function f sub y given that x is equal to x naught of y given that x is equal to x naught, which is, and now we're plugging in the constant x naught value, y is still a variable, over now the marginal f sub x, plugging in the constant, again over whatever support ends up happening when you fix the x value, and of course f sub x of x is the marginal, and I just noticed that this should just be of y as a function there. So in the next video, we'll go and apply these definitions in example 7.7.3, where we'll look at some conditional distributions of two variables x and y.